Hello students, welcome to my class. In this video we are going to be discussing about kinematics of circular motion problems we are discussing. So the first question says the angular speed of the flywheel, it's given as 120 revolutions per minute is they are asking. So flywheel is making 120 revolutions per minute, then angular speed they are asking. So let us take here angular speed. The formula will be getting as omega equals to, you can take as theta by t. So here theta in the sense here for one rotation you are taking as, this is here 2 pi radians will be taking. For n rotations in the sense theta value you can take as 2 pi n you can take. So instead of right, for one rotation 2 pi and for n rotations you are taking as the 2 pi n. So here you can take as 2 pi into n by t you can take. So now here you just convert this one, 2 pi into number of rotations or revolutions is given as 120 per minute they have given. You have to convert into seconds, and 62 times here will be getting as 4 pi radian per omega units will be radian per second will be getting. So this is the correct answer. Let us take the next question. In 1 second the particle is going to be goes from A to B point is given, moving in a semicircle of radius is given as 1 meter. The magnitude of the average velocity they are asking. Here it's a diagram is not given properly, students. Here B point you can take as here it will be moving in a semicircle is given. The particle is moving here in a semicircle up to this point. So here radius is given as 1 meter it's given, and here the magnitude of the average velocity they are asking. That means here average velocity, the formula will be, you can take as total displacement by, it's a total displacement by, here you can take as total time you can take, total displacement by total time you can take. Displacement doesn't mean here from A to B point, here you can take as total displacement it is 2r, by time is given as 1 second it's given. So here radius also is given as 1 meter. So here 2 into 1 by 1 you can take. So the average velocity will be getting as 2 meter per second will be getting. Let us see the next question. The next question says the length of the seconds hand in a watch is given as 1 centimeter, and the change in velocity, its a tip is given as 15 seconds. In 15 seconds they are asking. So here you can take, here you are taking on right in a wall clock. So here this is a clock you are taking, and here you can take this is seconds hand you can take. So initial velocity you can take as here, let us take as v, and here it's going to be completing some 15 seconds in the sense. So here let us take or else you can take in anti-clockwise clockwise manner you can take. Here this is the initial velocity. Now it's going to be completing 15 seconds in the sense, here seconds hand it will be coming over here, and this is the final velocity you can take after completion of the 15 seconds. So here in this case here we will be getting as delta v, which will be equal to change in velocity is nothing but v2 bar minus v1 bar you can take. Here that means here delta v, which will be equal to v2 bar here plus or minus, plus here you can take as minus v1 bar you can take. So here you can see here this is v2 bar will be along this direction will be getting, it's a v2 will be along this direction will be getting, and v1 here will be getting along this direction. Both the magnitudes of course it will be same will be getting. This is the v, resultant of these two will be getting as here along this direction, that is root 2v will be getting. But because these two vectors will be perpendicular to each other, according to the parallelogram law of vectors you can take as delta v equals to, here will be taken as root 2 into v you are taking. But here it's going to be moving in a circular motion, so v equal to, there is a relation between linear velocity and angular velocity, v equal to, here you can take as r omega you can take. For delta v, which will be equal to root 2 into v in the sense r into omega you can take. So here which is nothing but root 2 into radius is given as 1 centimeter. So answer it's given in centimeter, you need not convert the unit, students. So here this is 1 centimeter L1 you can take. Omega in the sense here you can take as 2 pi by time period in the sense here for one complete rotation you can take as 60 seconds you can take total time period. So here 230 times you will be getting here the change in velocity which will be getting as here pi into root 2 by here 30 you will be getting. This is in centimeter per second you can take. Let us see the next question. The next question says the angular speed of the seconds needle in the mechanical watch they are asking. Angular speed for the seconds hand in the sense here omega equals to here you can take as this is theta by t you can take, or you can take as 2 pi by t you can take. For seconds hand it's going to be making one rotation in 60 seconds. So 2 pi by 60 you can take here 30 times it is going. So here omega equals to here will be getting as pi by 30 radian per second you are getting. So it's a pi by 30 radian per second. Let us see the next question. The next question says what is an angular velocity of the earth they are asking. Angular velocity of the earth means here you can take as omega which will be equal to 2 pi by t you are taking. So here this is the radian per hour you will be getting here 2 pi by. So time in the sense here to complete one rotation it will take 24 hours. So you have to convert into 60 minutes into here you can take as 60 seconds you can take, which will be equivalent to omega equals to here you can take as 2 pi by this value will be getting as 86,400 will be getting. This is in radian per second will be getting. So this is the correct answer. Let us see the next question. The next question says the angular velocity of the particle rotating in a circular orbit 100 times per minute they are asking. So here angular velocity we need to calculate. Angular velocity is nothing but here angular displacement by time you can take. So here it's going to be completing n rotations in a minute. So here you can take as this is theta equals to here you can take as 2 pi n by t. So which is nothing but 2 pi into here n in the sense number of times in the sense 100 times you can take. Per minute you have to convert into seconds. 60 seconds and here is 0 and 2 5s and 2 3s will be getting 2 5s are 10. So here it is 10 pi by. So here it is 10 pi by 10 into here you can take as 3.14 by here you can take as 3 you can take. So here it's almost it is close to omega equal to here will be getting as 10.47 radian per second you are getting. Let us see the next question. The next question says a wheel completes 200 revolutions to cover 9.5 kilometers distance. Then the diameter of the wheel they are asking. So here you just look at students here distance covered. So for n revolutions in the sense distance covered for n revolutions which will be equal to here you can take as n into you can take as 2 pi r you can take. So which is nothing but n into here 2 pi into r in the sense here you can take as d by 2 you can take. Here 2 gets cancelled. It's nothing but here you can write it as n into pi into d you can write. Means here it's going to be completing 200 revolutions. So instead of n you have to take as 2000 revolutions. Instead of n I'm just taking pi into d. This is a distance. How much distance is covered in the sense 9.5 kilometers, which is nothing but 9,500 meters you can take. With this you have to calculate the diameter value. This is 9,500 by here you can take as it's 2000 into here you can take as pi you can take. So after simplifying this value here we will be getting as nearly 1.5 meter we will be getting. 1.5 is the correct answer. The next question says the ratio of the angular speeds of minutes hand and hour hand of the watch they are asking. Angular speeds of the minute hand in the sense here omega minute hand which will be equal to 2 pi by. So minute hand in the sense here I'm just taking here you can take as minute hand and hour hand they are asking. So here you have to take as minute hand it is going to be completing, to complete one rotation here it will take 60 minutes. So here I am just taking in radian per minute, I am just taking, and omega for hour hand, suppose you are taking, this is 2 pi by, so for complete one rotation it will take 12 hours, but here radian per minute I am just taking, here you have to convert the 12 hours into 60 minutes. So now you are getting this one also, it is in radian per minute you are getting. Now just they are asking the ratio. So here minutes hand to the, so omega hour hand they are asking, which is nothing but 2 pi by 60. So when you are bringing into the denominator, and if you are bringing into the numerator, it becomes 12 into 60 by, you can take as 2 pi, you can take 2 pi gets cancelled, 60 gets cancelled, here will be getting as 12:1 will be getting. Let us see the next question. The next question says here, an athlete completes one round of a circular track of radius 10 meter in 40 seconds. So now they are asking the distance covered by him in 20 seconds they are asking. So an athlete is given here, is going to be completing, there is a circular track is given of radius is given as 10 meter, and here he is going to be completing 40 seconds. So here a time it's given as, time period is given as 40 seconds it's given, and here the distance covered by him in 2 minutes 40 seconds. So number of revolutions doesn't mean, here you can write as number of revolutions, which will be equal to total time by time period, you can write. Total time by time period you can write. So total time you are getting as this is 2 minutes 20 seconds, means here nearly you will be getting as 60 plus 60, 120 plus 20, 140 will be getting, it's a 140 by, here total time period will be getting as 40 will be getting, and 2 7 are 2 2s are, so here we will be getting a 7 by 2, in the sense 3.5 revolutions he is going to be completing. Or else you can take 40, here 40 seconds, so total you will be getting as here 2 minutes 20 seconds, in the sense 140 seconds will be getting. So here you can take as 40 plus 40 plus 40 plus 20 you can take. So one two rotation, third rotation, and here 3.5 rotations he has been completed. Now distance covered is nothing but, here you can take as, so number of revolutions into here total circumference you can take, that is nothing but 3.5 into, you can take as 2 pi r you can take. So 3.5 into here you can take as 2 pi into radius. Radius is nothing but, here you can take as 10, you can take 10 meter itself is given. So together the value will be getting as 220 meter you are getting. Let us see the next question. The next question says here, a fan is moving, making 600 revolutions per minute. If after time it makes 1200 revolutions per minute they are given, then the increase in its angular velocity they are asking. First student, here it is given per minute is given, means this is frequency is given. So first you have to calculate the angular velocity. Omega equals to, here will be getting as here 2 pi n by t you can take. This is a basic formula you can take. It's nothing but 2 pi into n, in the sense here 600 revolutions. So per minute, in the sense you have to convert into 60 seconds. Here this 10 gets cancelled, 10 times 10 2s will be getting as 20 pi will be getting. This is the initial angular velocity. After some time it makes 1200 revolutions it's given. So omega 2 equals, here you can take as 2 pi, this is n1 you can take, and this is n2 by t you can take. 2 pi into, here you can take as 1200 by, here you have to convert into seconds, and here 10 gets cancelled, 620s are, here will be getting as 40 pi will be getting. Now here they are asking here, then increase in its angular velocity they are asking. Here delta omega is nothing but omega 2 minus omega 1 you can take, which is nothing but, here will be getting as 20 pi radian per second you are getting. Let us see the next question. The next question says, the seconds hand of the watch has length is given as 6 centimeter, and speed of endpoint and magnitude of the difference of velocities at the two perpendicular positions they are asking. So the second hand, length is given as 6 centimeters is given. So here its length is given as 6 centimeters. And speed of endpoint and magnitude of the difference of velocities at the two perpendicular positions they are asking. So here this is one velocity you have to consider while it's moving, and here this is a velocity. The moment when it comes here you can take as this velocity, you can take as v like this. And here first we need to calculate the velocity, speed at the end point they are asking. Here v equals, the formula, relation between linear velocity and angular velocity, v equal to r omega you are taking. So radius is given as, radius is nothing but length of the watch hands, seconds hand you can take. That's nothing but here we will be getting as 6 centimeters. So here you have to convert into, this is here millimeters you have to convert. This is 6 centimeters, 1 centimeter equals to, here you can take as 10 millimeters you can take. So together we will be getting a 60 millimeter, you will be getting millimeter per second, millimeter you are getting. Omega is nothing but here you can take as 2 pi, it's 2 pi by, here time you can take as for seconds clock it's going to be taking for one rotation. So time period is nothing but 60 seconds you can take, this 60 gets cancelled. Here we will be getting as 2 into 3.14, which is nothing but here 6.28 millimeter per second we will be getting. This is the velocity. Now here we need to calculate the magnitude of change in velocity. Magnitude of change in velocity. So here magnitude of change in velocity is nothing but here you can take as, this is v2 bar minus v1 bar you can take. So here delta v, which will be equal to, here both will be perpendicular in this, here let us take as v1 square plus v2 square. Both the magnitudes will be same, so that v square plus v square will be getting as root 2v, or else you can take as 6.28 whole square plus 6.28 whole square you can take. So here it's nothing but here we will be getting as 6.28 into, here we will be getting as root 2 will be getting. So when you are simplifying this one, root 2 you can take as 1.414 you can take. Here delta v is nothing but here you can write it as nearly 8.88 millimeter per second you are getting. So here the first one answer will be 6.28 and 8.88 millimeter per second is the correct answer. Let us see the next question. The next question says here, a body is whirling in a horizontal circle of the radius is given as 20 centimeter. It has an angular velocity 10 radian per second. What is the linear velocity at any point on a circular path they are asking. So you know the relation between linear velocity and angular velocity is v equal to r omega you can take. The radius is nothing but here you can take as 20 centimeter, 20 into 10 power minus 2 into here omega is nothing but 10 radian per second will be getting, and here this 100 and here it will get cancelled. So here linear velocity will be getting as, this is 2 meter per second will be getting. Let us see the next question. The next question says, an aeroplane is flying with a uniform speed of 100 meter per second along a circular path of radius is given as 100 meter. The angular speed of the aeroplane they are asking. So you know the relation between linear velocity and angular velocity equal to v equal to r omega you can take. So omega when you are talking here you can take as v by r you can take. V value is given as 100 meter per second, by radius also it's given as 100 meter, and you just cancel here the angular speed which will be equal to 1 radian per second will be getting. Let us see the next question. The next question says here, what is the value of linear velocity if omega and r bar value is given? So cross product here you can take linear velocity and angular velocity will be V equal to, here you can take as omega bar cross R bar, you can take, students. So don't take it as R bar cross omega bar. Here sign values, it's going to be changes. By using the product rule here, determinant rule, here V bar which will be equal to, so first you have to take the Cartesian coordinates. That's nothing but here I bar, I cap, j cap, k cap you can take, and here omega components you can take 3, minus 4 and as well as plus 1, and R bar components you can take as 5, minus 6, plus 6, plus 6 you can take. So which is nothing but here you can take as V bar equals to here. So by using here you can take as, this is AD minus BC principle, right? So here when you are taking here, you just take first row and first column you have to omit, and here this is, let us take it as ABCD. So AD minus BC just cross multiply, here I cap into, like you can take as minus 4 into 6, minus 24, minus BC. BC is nothing but here will be getting as minus into minus plus, here will be getting as plus 6 will be getting. In the same way here you can take as second row and second column, first row and second column you have to omit. So with that we will be getting as first row and second column you have to omit, and here we will be getting as minus j cap into, so here 3 6 are 18 will be getting. So here you can take, this is 3 6 0, and here 1 into 5 you can take. So it's nothing but here we will be getting as 18 minus 5, and now here you can take as the next plus k cap into, here you can take as, this is 3 into 6 and minus 4 into 5 you can take. 3 into minus 6 will be getting as minus 18, here minus into minus plus, 5 4s are will be getting as 20 will be getting. So here when you are simplifying this one here, together we will be getting as minus 24 plus 6, here we will be getting as minus 18 I cap, minus 13 j cap, plus here we will be getting as 2k cap will be getting. So that is the correct answer. Minus 18 I cap, minus 13 j cap, plus 2k cap is the correct answer. Let us see the next question. The next question says the angular velocity of the wheel is given as 70 radian per second. And if the radius of the wheel is 0.5 meter, the linear velocity they are asking. You know the relation between the linear velocity and angular velocity is V equal to R omega, which is nothing but radius is given as 0.5 meter and its angular velocity is given as 70 radian per second. So this 10 and this decimal you have to cancel, 570 will be getting as 35 will be getting. This is 35 meter per second is the correct answer. Let us see the next question. The next question says here, a scooter is going round in a circular road of radius is given as 100 meter at a speed is given as 10 meter per second. The angular speed of the scooter will be there asking. So angular speed doesn't mean here you can take as, this is V equals to linear speed and angular speed, this is a relation. Then omega equals, here you can take as V by R you can take. V will be getting as 10 will be getting, radius value here it's given as 100 meter it's given. So 10 times right it's going. So here 1 by 10 is nothing but here will be getting as 0.1 radian per second will be getting. This is 0.1 radian per second is the correct answer. Let us see the next question. The next question says here, a stationary wheel starts rotating. It starts rotating about its axis at uniform angular acceleration of 8 radian per second square it's given. So here it starts rotating in the sense initial angular velocity you have to consider as 0. And here it's an alpha is given as 8 radian per second square it's given. The time taken to complete 77 rotation, n value they are given. So time value they are asking, first let us take as theta equals to angular displacement will be 2 pi n you can take for n number of the rotations. So 2 into pi value I am writing as 22 by 7 into n value. Number of rotations is given as 77, 7 11 there we can take. So here 2 into 11 will be 22, 22, 22 there here will be getting as 484 radians will be getting. Now here you know the angular displacement. To calculate the time here which will be equivalent to here you can take as omega naught t plus half into alpha into t square you can take, which is theta value you know already 484. Initial angular velocity will be 0 into t will be 0 you can take, and here it will be 0 you can get. Half into alpha value it's given as 8 into t square you can take. So 2 4s are will be getting, and 4 1s are 4 2s are and 4 1s are. So here that doesn't mean t square equal to 121 you are getting, then t value will be getting as 11 11s are 121. So it's 11 seconds will be getting time value. Let us see the next question. The next question says here, a stationary wheel starts rotating about its own axis at constant angular acceleration. If the wheel completes here 50 rotations in the first 2 seconds, then the number of rotations made by it in the next 2 seconds they are asking. Wheel starts rotating it's given, so that you have to consider the initial angular velocity will be 0. And here for time t equal to 2 seconds let us calculate. Here this is t equal to 2 seconds you can take. Now here you can talk as so angular displacement which will be equal to theta equals to 2 pi into, here it's going to be completing 50 rotations. So here 50 you can take, it's nothing but 100 radiations will be getting. Now theta equals to angular displacement, you know the formula omega naught t plus, here you can take as half into alpha into t square. So let us take here directly, or else you can take as directly. Initial angular velocity will be 0 into t will be 0. Anyhow, with the same angular acceleration the body is going to be moving wheel, and theta which is directly proportional to t square you can take. So theta is nothing but here will be getting as 2 pi n here, or else here you can take as initially here it's going to be making final value you can take n number of the rotations. Initial number of rotations is given as 50, or else here you can take as theta 2 by theta 1 which will be equal to, here you can take as t2 square by t1 square you can take. So it is nothing but here will be getting as t2 square, in the sense here they are asking us next 2 seconds. Next 2 seconds in the sense here you can take as this is 2 plus 2 will be getting as 4 square by, here you can take as 2 square you can take. So here 4 4 are 16, 16 by 4 will be getting as 4 will be getting. So which is nothing but here you can take as this is also 2 pi into 50 rotations. So 2 pi gets cancelled. Here you can take as n by 50 which will be equal to 4 will be getting, then n value will be getting as so nearly 200 rotations we are getting. And it's 200 rotations. Let us see the next question. The next question says here a flywheel is given and which is making 120 revolutions per minute. So whenever they are given revolutions per minute or rotation per second, frequency is given, students. Here first you have to calculate here making 120 revolutions. Let us calculate initial angular velocity which will be equal to theta by t you can take. Number of rotations if it is making is theta equals to 2 pi n. For one rotation is 2 pi radians. For n rotations we can take as theta equals 2 pi n by t you can take. It's nothing but 2 pi into here will be given as 120 by time it's given as per minute they have given 60 seconds you can take 2 times. So 2 2s will be getting as 4 pi radian per second you are getting. Now here omega final value here acted upon by retarding torque is given, producing angular retardation of pi radian per second square. Let us calculate here retardation of pi radians, the time taken by it to come to the rest. So omega final which will be equal to omega initial value plus alpha into t. This is the formula you can take. Finally it comes to the rest, final angular velocity will be 0. Initial angular velocity we have calculated as 4 pi. It's a retardation is given as right, instead of alpha here it is given as minus pi radian per second square it's given. So here you can take as minus pi into, here you can take as t you can take. So 4 pi equals, here you can take as pi into t, and pi gets cancelled. Then here we will be getting as t equal to, here we will be getting as 4 seconds we are getting. Let us take the next question. The next question says a circular disc is rotating about its own axis at a constant angular acceleration if its angular velocity increases from 210 revolutions per minute to 420 revolutions per minute during 21 rotations, then the angular acceleration of the disc they are asking. So initial angular velocity you have to calculate, students, which is nothing but 2 pi n by t. 2 pi into number of rotations is given as 210 is given initially, per minute it's given. So here you can take as 60, you can take 110 gets cancelled, and here you can take as 3 7 3 2 you can take, and this 2 gets cancelled. Here we will be getting as initial angular velocity is 7 pi radian per second you are getting. In the same way, you just calculate the final angular velocity, that is 2 pi into, here it is. So directly you can take here, this is 2 times it is increasing, means 2 times of this 7 pi, 420 rotations it's completed. So here you can take as 2 into 7 pi you can take directly. You need not use this formula alone, which will be equivalent to, here we will be getting as 14 pi radian per second we will be getting. So theta is an angular displacement we will be taking. 2 pi into how many rotations it is completing, means here 21 rotations it is completing. So here theta equals to 2 pi into 21 you can take. Then here we need to calculate the angular acceleration of the disk. So that's nothing but omega final whole square minus omega initial whole square, which will be equal to 2 into alpha into theta you can take. Omega final is nothing but, here we will be getting as 14 pi whole square, means 14 that we will be getting as 196 pi square, minus omega 1 in the sense 7 pi square, which is nothing but, here we can take as 49 pi square, which will be equal to 2 into, it's an alpha into theta value 221 42 pi you can take. So it's 196 minus 49 you will be getting as 147 you will be getting 147 pi square, which will be equal to, here this is 84 we will be getting alpha into, this is pi into alpha you can take, students. Here 1 pi gets cancelled. Then alpha equals, here we will be getting as 147 pi by, here we can get it as 84 we will be getting. That's, here you can get it as 147 by, this is 84 into pi you can get it as 22 by 7. So here 7 2 7 1 we will be getting, and here this is 21 4 we will be getting. So 22 by 4 we will be getting as, this is nearly 5.5 radian per second square we will be getting. Let us see the next question. The next question says a circular disc is rotating about its own axis at uniform angular velocity omega. It's omega, student. The disc is subjected to the uniform angular retardation by which its angular velocity decreases to omega by 2 during 120 rotations. Then the number of rotations further it made by before it comes to the rest. So before it coming to the rest, here how many number of the oscillations it is going to be completing. You know the basic formula, students. Here omega final whole square minus omega initial whole square, which will be equal to, you can take it as 2 into alpha into theta. In the first case, here initial angular velocity will be omega, and here it is decreased to omega by 2. So here you can take it as final angular velocity is omega by 2 whole square minus initial angular velocity will be omega square, which will be equal to 2 into alpha into theta. In the sense, here you can take it as 120 rotations it's completing. So here you can take it as 2 pi into, here you can take it as 120 you can take. Whereas in the second case, here it's given as it comes to the rest. The number of rotations further it made before it comes to the rest. Means here you can take it as final angular velocity will be taken as 0. Initial angular velocity, you know, students, here omega square you can take, which will be equivalent to, here you can take it as 2 into alpha into 2 pi into, here you can take as, instead of theta you can take as n you can take. So here you have to cancel, this is 2 alpha gets cancelled, and here 2 pi gets cancelled. Omega by 2 whole square nothing but, here we will be getting as 1 by 4 minus 1, this is minus 3 by 4 omega square. In denominator we will be getting as minus omega square, you have to bring it to the denominator, minus gets cancelled, omega square gets cancelled. Here we will be getting as, this is 120 by n we will be getting. So here you just multiply students for 3, 40 times it's going. So here number of rotations, in the sense here you can take as number of rotations, here we will be getting as 4 into 40 will be getting as 160 will be getting. But here in the question is given as the number of rotation further made by it before coming to the rest. That means here n final when you are talking, here you can take as it's 160. Initially it's going to be making as 120 rotations, 160 minus 120 you can take, which is nothing but 40 rotations will be getting. So 40 rotations is the correct answer. Let us see the next question. The next question says here, a ceiling fan is rotating about its own axis with an initial angular velocity is omega. The electric current is switched off. Then due to the opposing torque, its angular velocity is reduced to 2 omega by 3. It's completed 30 rotations. The number of rotations further it made before coming to the rest, they are asking students. So the same scenario like in the previous case, here omega final whole square minus omega initial whole square, which will be equal to, you can take as 2 into alpha into theta you can take, which is nothing but final angular velocity will be, first case it's 2 omega by 3 whole square you can take, minus initial angular velocity will be omega square, which will be equal to 2 into alpha into theta is nothing but for n number of rotations 2 pi n you can take. So here 2 alpha into, here you can take as 2 pi into n number of the rotations is given as 30. So this is the first case you can take students, and here in the second case it comes to the rest. So 0 minus, here you can take as omega square, which will be equivalent to here 2 into alpha into theta, in the sense again you can take as 2 pi n. So here 2 alpha and 2 pi gets cancelled. So 2 by 3 whole square means 4 by 9, 4 by 9 minus 1, in the sense here we will be getting as this is 4 by 4 minus 9, it's minus 5 by 9 into, here we will be getting as omega square, in denominator we will be getting as minus omega square we will be getting, we just bring into the denominator. So minus gets cancelled, omega gets cancelled, here we will be getting as 30 by n. So here 6 times it is going, and here n value will be getting as, this is 960 will be getting as 54 rotations. Then final rotations, in the sense here final rotations, in the sense here actual rotations will be 54. Initially it's going to be making as 30 rotations, so here we can take as 24 rotations will be getting. This is 24 is the correct answer. Let us see the next question. The next question says here, a wheel has a speed is given as 1200 revolutions per minute, and it's made to slow down at the rate of here 4 radian per second square. The number of revolutions it makes before coming to the rest they are asking. Now here initial angular velocity you can take omega initial, which is nothing but here 2 pi into, here you can take as n by t. So here 2 pi into n, in the sense here number of revolutions is 1200 per minute, in the sense 60 is given, and here 110 gets cancelled, 620 times 20 into 2 will be getting as 40 pi will be getting, this is radian per second will be getting. Then alpha value is given as here in the question as 4 radian per second square it's given. The number of revolutions it makes before coming to the rest. So here omega final whole square minus omega initial whole square, which will be equal to, here you can take as 2 into alpha into theta you can take. So its final value will be 0 minus initial angular velocity we got it as 40 pi whole square, which will be equals to 2 into alpha value it's given as 4 it's given, and here theta value you can calculate. Theta is nothing but here you can take as 2 pi into n you can take. So here it's a retarding value, so here we will be getting as a right number of revolutions it make before coming to the rest, means here it is retarded here, so instead of alpha minus alpha you can take, and here this minus minus gets cancelled, here 40 pi square, 40 whole square in this sense 40 0 will be getting a 1600 into pi square, which will be equal to, so 2 4s are 8, 8 2s are 16 will be getting, or else here 8 into here you can take as 2 pi into n you can take. So here you can take as 1 pi and this pi gets cancelled, 8 2s are 16, so 16 10 times it is going, 10 into 100 will be 100 will be getting, this is 100 pi will be getting, that's n value. So here n is nothing but here will be getting as 100 into 3.14 you can take, which is nothing but 3.14 into 100 is here nearly will be getting as 314 will be getting. These are the number of rotations. Let us see the next question. The next question says here a ceiling fan is rotating at the rate of inertia is given. Here the moment of inertia of the rotating fan is given as this is 12.5 kg meter square. If the current is switched off, the fan comes to the rest in 5.5 seconds. Then here the torque acting on the fan due to the friction they are asking. So initial angular velocity here it will be, this is you can take this here the fan comes to rest in 5.5 seconds is given. Current is switched off. So here omega final value, omega initial value you can take right 2 pi into here some correction is there students here. Moment of inertia, if the current is switched off, the fan comes to the rest is given. So here a small correction is there students, here at the rate of, here it is given as this is 3.5 rotations per second. So it's a rate of at the rate of 3.5 rotations per second of, and inertia is 12.5 kg meters. So if the current is switched off, the fan comes to the rest. So initial angular velocity you have to calculate students. Here in this case initial angular velocity is omega initial, which will be equal to 2 pi n by t you can take, which is nothing but here you can take as 2 pi into, this is number of rotations per second is given as 3.5 rotations per second. So 3.5 I am just writing as 7 by 2, so 2 gets cancelled, here you can take as 7 pi radian per second you can take. This is an initial angular velocity. Omega final value will be getting as 0, it comes to the rest. So in a time is given as here 5.5 seconds, that we can take as 11 by 2, which is nothing but 5.5 seconds. So omega final here alpha angular acceleration is omega final minus omega initial by t you can take, which is nothing but here you can take as, this is omega final value will be 0 minus omega initial value will be getting as 7 pi by time you can take as 11 by 2 you can take, which is nothing but here will be getting as alpha value will be getting as nearly here this is 2 7 are 14, or else here pi value you can take here which is nothing but minus 7 into it's 22 by 7 into, here you can take as 11 by 2, you have to bring it to the numerator. So this 7 gets cancelled, 11 2 times, 2 will be getting as 4. So alpha value will be getting as minus 4 radian per second square you are getting. So here current value they have given and torque acting on the fan due to the friction they are asking. So relation between torque and angular acceleration will be tau equals to, here will be taken as I alpha. Moment of inertia is given as, here it is I value, here you can take students, this is it's not 12.5 students, here you can take this is 1.25 kg meter square. So here you can take this is 1.25. So here this is 1.25, here this is an I value, here you can just make a correction, this is 1.25 kg meter square. 1.25 I can write it as, this is nothing but 5 by 4 you can take, into alpha value you will be getting as 4. So this is a minus 4, here 4 gets cancelled, here torque will be getting as 5 Newton meter you are getting. So 5 Newton meter is the correct answer. Let us take the next question. The next question says here, a circular disc is rotating about its natural axis, and here a constant opposing torque is given as, here 2.75 Newton meter is applied on the disc, due to which it comes to the rest in 28 rotations. If the moment of inertia of the disc is given as 0.5 kg meter square, the initial angular velocity of the disc they are asking. You know the relation between torque and angular acceleration, students. Here torque equals to tau equals I alpha. With this, here alpha you just calculate angular acceleration, tau by I you can take. So tau value is given as, torque is given as, here it will be 2.75 Newton meter. It's 2.75 by initial this is moment of inertia is given as 0.5 is given. So 0.5 you can take as 1 by 2, 2 into, here it will come to the numerator, 2.75 into 2, you can write it as, alpha value will be getting as 5.5 radian per second square you are getting. So here a circular disc is rotating about its natural axis. Right, here initial angular velocity is given, is applied on the disc, due to which it comes to the rest. Final angular velocity is given as, final angular velocity will be 0. Here we need to calculate the initial angular velocity of the disc. So here it's going to be completing theta equals to, here 28 rotations it's going to be completing. So theta equals to 2 pi you can take, 2 pi into 28 I am just taking. So here you just take the formula, omega final whole square minus omega initial whole square, which will be equal to 2 into, here it's going to be retarded due to the opposing torque, here minus 2 into minus alpha into theta you can take. So here omega final value, here it will be 0, and here this is, this side here minus and minus you have to cancel. Here omega initial whole square, which will be equal to 2 into alpha we got it as 5.5 into theta is nothing but its number of rotations is given as 2 into 28. Here it is 56 pi you will be getting. Then here omega initial you just calculate, students, 2 into this 5.5 I am writing as 11 by 2 into, you can take as 56 into, here this pi value again you can take as 22 by 7. So here you have to cancel this one, 7 8 0 you will be getting, and here 2 11 0 you will be getting, which is nothing but here 11 8 0 88 into, here 2 11 0 you will be getting as 22 you will be getting, which is nothing but omega initial whole square, which is nothing but when you are multiplying this is 1936 you will be getting. That means here omega initial value will be getting as, this is 44 radian per second you are getting. So omega initial value we have calculated. Now here, but in the options here initial angular velocity they have asked, but in the options is given as frequency they are talking. These are all the frequency values. So frequency how we can calculate in this sense, omega initial value here you will be getting as 44 radian per second. Omega in this sense here you can take as 2 pi n by time you can take as 60 seconds. Here they are asking in per minute they are asking. per minute. This is radian per second, and here 2 pi n by 60 you can take, which will be equal to 44 it's given. Then n number of the rotations we just calculate. For n number of the rotations, here you can take as this is 44 into 60 into 44 by, here you can get it as 2 into pi value you can take as 22 by 7 you can take. So 22 2s are, this 2 gets cancelled, 60 into 7. So here we will be getting as 420 rotations per minute we will get. So this is the correct answer. Let us see the next question. The next question says here, a constant torque acting on a body of 100 Newton meter, right? Torque is given as, right? Torque here it is 1000 Newton meter it's given. It turns a wheel of moment of inertia 200 kg meter square. I equals to, here you can take as 200 kg meter square it's given. About an axis through its center. Its angular velocity after 3 seconds they are asking. Right. Here tau equals to, here you can take students, here it's nothing but I alpha, which is nothing but torque it's given as 1000. Here I value is given as 200 into alpha value. So 200 5 times it is going, but alpha equals, here we will be getting as 5 radian per second square. So here you can calculate omega final value, which will be equal to, here we will be getting as omega initial plus alpha into t you can take. Initial angular velocity will be 0 plus, here we will be getting as alpha you can get it as, this is 5 into, here time value will be getting as 3 seconds, which is nothing but, here we will be getting as 15 radian per second we will be getting. This is the final angular velocity. Let us see the next question. The next question says here, a flywheel of moment of inertia 0.4 kg meter square is free rotate in a vertical plane about the horizontal axis, passing through its center. Its moment of inertia is given initially without friction. An external torque 10 Newton meter is acting on a flywheel, which is initially stationary. So here the angular velocity of the wheel when it completes 100 by pi rotations they are asking. Now here you just look at students, here initial torque tau equals to, here you will be getting as I into alpha. With this here torque it's given as 10 Newton meter, I value is given as 0.4 kg meter square, alpha we don't know, we just calculate. Then alpha equals, here we can get as 10 by 0.4, which is nothing but, here we will be getting as 10 by, here we can get as 4 by 10. 425 times we will be getting, this is nothing but, here we will be getting as 25 radian per second we will be getting. So initial angular velocity is given as 0 is given, and here you can get as theta equals to, here you can get it as 2 pi into, and it completes 100 by pi rotations. So here n in the sense, here you can get it as 100 by pi you can take. Theta equals, for n rotations 2 pi n will be getting, 100 by pi you can take, pi gets cancelled. Then here 2 into 100 will be getting as 200 will be getting. So this is nothing but 200 radians will be getting. Then angular velocity doesn't mean final angular velocity they are asking. Omega final whole square minus omega initial whole square, which will be equal to 2 into alpha into theta you can take. Omega final whole square, which will be equal to, here this is 0. 2 into alpha value we have calculated as 25, and here it's nothing but theta value will be getting as 200. We just simplify this one, omega final whole square, which will be equal to, so 2 into 25 will be getting as 50 into, here will be getting as 200. This is 5 2s are 10, and here we will be getting as nearly 10 power 4 will be getting. So then omega final value will be getting as 10 square will be getting, which is nothing but 100 radian per second. This is the omega final value. Let us see the next question. The next question says, when a ceiling fan is switched off, its angular velocity is reduces to 50% while it makes 36 rotations. How many more rotations will it make before comes to the rest? So here n value they are asking, further n value. So you know the relation omega final whole square minus omega initial whole square, which will be equal to 2 into alpha into theta. You can take omega final in the sense 50% it is reducing, means initial angular velocity. Let us take here it's omega naught is the initial angular velocity. Here it's going to decreases 2, it's given, it decreases to 50%. It's omega naught by 2 you can take. Initial angular velocity you can take it as omega naught square you can take, right, which will be equivalent to, here you can take it, this is 2 into alpha into theta, in the sense here you can take it as 2 pi into, here it's going to be completing 36 rotations. So here you can take it as 36. Let us see the next scenario. How many more rotations it will take before come to the rest? So how many more rotations will it take before comes to the rest? How many more rotations, in the sense here you can take it as final angular velocity will be 0. How many more, in the sense here where it is going to be decreasing, from there itself it's going to be, we have to take the initial angular velocity. So it's omega naught by 2 whole square you can take. So here by here will be getting us 2 into alpha into theta value you can take as 2 pi into, here you can take as n you can take. 2 alpha, 2 pi gets cancelled. Here 1 by 4 minus 1, here will be getting as minus 3 by 4 will be getting, minus 3 by 4 omega naught square by, this is omega naught square by 4 will be getting, we just bring it to the numerator, minus 4 by omega naught square you can take. Here omega naught square gets cancelled, 4 gets cancelled, which will be equal to 36 by n you are getting. So here 3 here will be getting as, this is 36 here on, this is here 4 gets cancelled, here on, this is so 36 by n. This is here you can take this omega naught square by 2. It is here, sorry students, here initial angular velocity I would consider omega naught square alone. Here this is here minus 4 will be getting, here omega naught square, this is here will be getting as omega naught 1 by omega naught square will be getting, omega naught square gets cancelled. Here you can take as, this is together will be getting as 3 by 4, which will be equal to 36 by n will be getting, 3 12s will be getting, so n value will be getting as 4 into 12 will be getting as 48 will be getting. How many number of more rotations it will make before coming to the rest? So final angular velocity will be 0, initial angular velocity I would consider as omega naught we can take. So here we will be getting as n value will be 48 will be getting. Let us see the next question. The next question says here theta equals to, here it's given as theta naught plus, here theta 1 t plus, here it's given as theta 2 t square it's given. Then the angular acceleration of the body. So omega you just calculate students, omega is nothing but d theta by dt, which is nothing but, here you can take that this is a constant value, it will be 0, and here when you are doing differentiation, this one theta 1 plus, here t square in the sense 2t will be getting, 2 into theta 2 into t will be getting, this is omega value. Then alpha is nothing but, again here you can do the differentiation to the omega, so now it becomes a constant value. Here we will be getting as 2 theta into t, in the sense 2 theta 2 into, here d by dt of t will be getting, it's a 1 will be getting, so alpha value will be getting as 2 into theta 2 will be getting. Let us see the next question. A car of mass is given as 200 kg. It's a round shape curve of radius is given as 250 meter, and here it's moving at the 90 km per hour it's given, right? Here speed is given as, here 90 km per hour, 1 km per hour equals, here you can take as 5 by 18 meter per second. It's a practical unit students, you have to convert into the SI units. Here 5 by 18 meter per second will be getting, 8 in 5s are 5 5s are will be getting as 25 meter per second will be getting. So here we need to calculate the angular speed. Here v equals to here will be getting as r omega. Then here omega equals here we can write it as v by r we can take, which is nothing but v value will be getting as 25 by r value. Radius is given as 250 is given. 25 ones are 25 tens are will be getting. So omega is nothing but 1 by 10 is nothing but here you can get as 0.1 radian per second will be getting. This is the omega value. Let us see the next question, students. Here the next question says here, the figure shows the angular velocity versus time graph is given of a flywheel. The angle in the radians they are asking, which is flywheel runs during 25 seconds they are asking. So omega equals, the formula, students, here theta by t, and here so they are asking here the angle in which the angle in the radians they are asking, means theta they are asking. Theta is nothing but here you can take as omega into t. That doesn't mean here you can take as area under here you can take as omega versus t graph you can take. Omega versus time graph you can take. Here it's a trapezium. Trapezium formula will be area of trapezium you can take, students, here which will be equal to sum of the parallel sides, like half into a plus b into you can take as h you can take. So sum of the parallel sides, a plus b in the sense sum of the parallel sides into you can take as h you can take, right? Distance between them, right? This is h is nothing but distance between them you can take, distance between them, and here this is the sum of the parallel sides, sum of parallel sides you can take, which is nothing but here you can take as half into one parallel side. This is the parallel side, students. Here up to here it is 25 will be getting. This is one parallel side 25, and one more parallel side you can take as this is here you can take as 30. So here up to here 25 they are talking to, this is here 20 minus 5 will be getting as 15 will be getting one more parallel side into h in the sense here distance between them will be getting as 30 will be getting. So here 15 times it's going, 25 plus 15 will be 40 into 15. So that's nothing but here theta value will be getting as nearly 4 5 are here 600 will be getting. Right, this is 600 is the rotation, so it's going to be completed. Let us see the next question. The next question says the motor of an engine is rotating about its axis with an angular velocity of 100 rotations per second a minute it's given. It comes to the rest in 15 seconds after being switched off. Assuming constant angular deceleration, what are the number of revolutions made by it before coming to the rest they are asking. So here we just calculate the initial angular velocity, students. Initial angular velocity here you can take as omega I you can take. This is nothing but 2 pi into n by t you can take. It's 2 pi into here n number of the rotations in the sense 100 rotations per minute they have given. So here you can take as 60. So here 1 10 gets cancelled, and here you can take as 2 5s are 2 3s are you can take 2 5s are will be getting as 10 pi by 3 will be getting. So here omega final when you are calculating, here omega final which will be equal to omega initial plus alpha into t you can take, students. Finally it comes to the rest. So initial angular velocity will be 10 pi by 3 which we have calculated. So it's coming to the rest in the sense it is going to be retarding, so that minus alpha I am just taking into time is given as here it is given as 15 seconds is given. So now we just calculate the angular acceleration, students. Alpha equals here you can get as 10 pi by 3. So here this is 10 pi by 3 into 15 you can take. And you are simplifying this one, alpha into 15 you have to bring this here, then you just calculate the alpha value. So 5 2s are 5 3s are will be getting, here it is nothing but 2 pi by 3 3s are will be getting as 9 will be getting, and this value approximately will be getting as 0.7 radian per second square you are getting. Now here we just calculate this is number of rotations we need to, what are the number of revolutions made by it we need to calculate. Then here to calculate the number of rotations, here you know the formula omega final whole square which will be equal to omega initial whole square plus here you can take as 2 into alpha into theta you can take. Final angular velocity will be 0. Initial angular velocity, you know, here it's we got it as 10 pi by 3. You just square on both sides. It's nothing but here we'll be getting as 100. Here 100 into you can take as pi square you can take. This is 9 you can take. 100 pi square by 9 minus 2 into alpha value. Alpha we got it as 0.7 we are getting into theta you can take, which is nothing but 2 pi into n you can take. So just bring this side, students. Here 100 pi square by 9, which will be equal to 2 into 0.7 into here you can take as 2 pi n you can take. So here this pi gets cancelled. Here you can get it as n value which we are getting as 100 into pi by. So here this is 9 into 2 2s are will be getting as 4 will be getting into you can take as 0.7 you can take. So here when you are simplifying this value, here nearly will be getting as 12.5 rotations will be getting, students. So 12.5 is the correct answer. Let us see the next question. The next question says here a wheel is subjected to the uniform angular acceleration about its axis. Initially its angular velocity is given as 0. So initial angular velocity is given as 0. Now here in the first 2 seconds it rotates through an angle theta 1 it's given. And here in the next 2 seconds here it rotates through an angle theta 2 is given. The ratio of theta 2 by theta 1 they are asking. So here initial angular displacement in the sense theta equals to here you can write as omega initial into t omega t plus half into alpha into t square you can take. So theta which will be equal to 0 plus here half into alpha value into t square in the sense here you can take as 2 square you can take, which is nothing but here will be getting as 2 alpha. So theta, this is, let us take as theta 1 you can take. Theta 2 which we calculated as half into alpha into. So next in the sense here you can take as this is next time interval in the sense here you can take as this is 4 square minus half into alpha into 2 square you have to take, which you are getting as this is 4 4 that's 16, 16 by 2 it is 8. So 8 minus here will be getting as this is 8 alpha minus this is 2 alpha will be getting, which is nothing but 6 alpha will be getting. And here they are asking theta 2 by theta 1 they are asking, which is nothing but 6 alpha by here you can as 2 alpha. So here will be getting as 3 by 1 will be getting. So 3:1 is the correct answer. Let us see the next question. The next question says here a wheel is rotating at the rate of 900 rotations per minute about its axis. When power is cut off, it comes to the rest in 1 minute. The retardation in radian per second square they are asking. So omega initial value you can take as here 2 pi into here you can take as n by t you can take. It's 2 pi into n value. N in the sense number of rotations you can take as 900 by time value. So time here it is going to 60 seconds. Here you just cancel 6 15. Here 2 into 15 will be getting as 30 pi radian per second will be getting. So here you can take as omega final, which will be equal to omega initial plus alpha into t you can take. Omega final will be 0. Omega initial value you calculated as 30 pi. It comes to the rest in the sense it is retarding. So here time is given as 1 minute. Here you have to consider as 60 seconds. That doesn't mean here alpha you have to bring this set. Here alpha equals here will be getting as 30 pi by 60 will be getting. So here 2 times here will be getting as pi by 2 radian per second square will be getting. Let us see the next question. If the equation for the displacement of the particle moving in a circular path is given by theta equals to 2t cube plus 0.5, where theta is in radians and t is in seconds is given. So the angular velocity of the particle after 2 seconds they are asking. Angular displacement is given as 2t cube plus 0.5 it's given. And here we can take as omega equals to, you can take as d theta by dt. When you are doing differentiation, 3 to the 6, 60 square you are getting. At the time t equal to 2 seconds, here you just calculate, students, omega, which will be equal to 6 into 2 square. So here it's nothing but 24 radian per second we will be getting. So this is, here we will be getting as 24 radian per second. Angular velocity of at time t equal to 2 seconds they are asking. Let us see the next question. A constant torque of 100 Newton meter, torque is given as 100 Newton meter, turns a wheel of moment of inertia is given as 200 kg meter square about an axis through its center. Its angular velocity after 3 seconds they are asking. Here relation between torque and angular acceleration you can take as tau equal to I alpha. With this here alpha you can take as tau by I you can take. Tau value here it's given as 1000 Newton meter by this is I value is given as 200, which is nothing but here we will be getting as 5 radian per second square you are getting. So here you can take as omega final, which will be equal to, here we will be getting as omega initial plus alpha into t you can take. Initial angular velocity will be 0 plus alpha you can take as 5 into time is given as 3 seconds. So here omega final you can take that this is 15 radian per second you can take. This is the final angular velocity. Next, look at the next question. Here a table fan it's given is rotating at a speed of here 2400 rotations per minute, is switched off, and the resulting variation of the RPM with the time is shown in figure. The total number of revolutions of the fan before it comes to the rest they are asking. Which doesn't mean here this is frequency versus time graph is given. Here you can take, students, here area under frequency versus time graph gives, this is theta equals to basic formula will be getting as 2 pi n by t. Theta frequency versus time graph gives the total number of revolutions you can take, gives the total number of revolutions before coming to the rest. So area you just calculate, students, here you can calculate area is nothing but here we will be getting as total number of total number of revolutions will be getting. Total number of revolutions, which is nothing but here you can take for this area, here it's a triangle, here half into base, in the sense here you can get it as, here it is 8 into, you can take as height, you can take as 2400 minus 600, so here it is in 1800 rotations per minute they are asking by 60 you can take, you have to convert into seconds, plus, and the next you can take for this for this one, here we will be getting as here 8 rotations, 8 will be getting, base will be 8 into height, in the sense here we will be getting a 600 rotations per minute, 60 you can take, plus again one more triangle you will be getting here, this triangle you can take, so plus half into base value here we will be getting as, it is 16, students, it is coming to the 16. 600, here it's not given anything, here it is I think 24, students, this value will be 24 minus 8 will be getting as 16 will be getting into, you can take as here 600 per 60 you can take. Now here you have to cancel students. Here this is 110 gets cancelled, 630 is there, and here 2 4s are 4 into 30 will be getting as 120 plus this is 60 into 10 times, and here this is 80 plus this is 60, 10 times it is going. Here 2 8s are 8 into 10 will be 8 will be getting. So this is 200 and 200 plus 8 will be getting as 280 will be getting. So number of rotations will be 280 will be getting students. Here this value will be 24 you can take students. Let us take the next question. A wheel is at rest. Its angular velocity increases uniformly and becomes 80 radian per second after 5 seconds. The total angular displacement they are asking. So here alpha equals to, here you can take as students, here omega by t. Its omega value is given as initially as 80 radian per second. Here it's 5 seconds is given, 516 times. So angular acceleration will be getting as 16 radian per second square will be getting. Now here you just calculate. Initially rest is given, student. Direct formula you can take. Here this is omega final minus omega, which will be equal to omega initial plus alpha into t you can take. This value will be 0, and here omega equal to alpha into t will be getting. Alpha equal to, here you can take as omega by t, then alpha value will be getting as 16 radian per second square. Then here the total angular displacement they are asking, theta equals to, here you can take as omega it plus, here you can take as half into alpha into t square you can take. So theta, which you can take as 0 plus half into alpha value will be getting as 16, t square in the sense here 5 5s will be getting as 25, so 2 8s will be getting, then theta value will be getting as 200 radians will be getting. Let us see the next question. The next question says here, a rigid body rotates about a fixed axis with the variable angular velocity is given as alpha minus beta is given at the time t, where alpha and beta are constants, the angle through which it total rotates before coming to the stops. Initial angular velocity is given, students, which is nothing but alpha minus beta into t. Now here alpha and beta are constant is given. It's in the form of here omega final, which will be equal to omega initial plus alpha into t. So here, whereas instead of alpha, here it is given as beta is given. It's nothing but alpha equals to, here you can take as minus beta. So omega initial value is given as, here you can take as alpha is given. And this is the angular acceleration is given as minus beta. Initial angular velocity is given as alpha is given. Now here omega final whole square, which will be equal to omega initial whole square plus 2 into alpha into theta you can take. Theta value they are asking, students. Finally it comes to the rest. Omega initial is given as alpha square plus 2 into alpha value is given as minus beta into theta you can take. So when you are simplifying this one, here 2 into beta into theta, which will be equal to alpha square. Then here theta equal to, here will be getting as alpha square by, here you can take as 2 beta you can take. Alpha square by 2 beta. This is the correct answer.